So let's get back to what we were doing. Where did it go? Hide this and let's go. So this number 7 is an example of a trinomial multiplied by another trinomial. We're going to follow the exact same steps, y'all, that we've been following, okay? So what I told you was you take each individual term on this left-hand side, right, or just of a polynomial, and you multiply it to each individual term of your other polynomial. So let's go ahead and do that. I'm going to also use different colors here, okay? So here we're going to do these two multiplied together, those two terms multiplied together, these two terms multiplied together. Then we're going to do these two terms multiplied together, those two and those two, and then we will do those. Okay, and I'm going to use the same color, y'all. So let's go ahead and do it. I want to do it here just because I know I'm going to have to combine like terms too, and I think that right-hand side's not going to be enough for me. So let's do, I guess we would say like the dark blue. 2x squared times 2x squared. 2 times 2 is 4. Signs are the same, so it's positive. X squared times x squared is keep and add. 2x squared times 2x. 2 times 2 is 4. Signs are the same, so it's positive. X squared times x, keep and add. 2x squared times a negative 1. 2 times 1 is 2. Signs are different, so it's negative. X squared times no x squared is just x squared. Let's change to purple. Negative x times that right-hand side polynomial, that's a negative 1, right? So 1 times 2 is 2. Signs are different, so it's negative. X times x squared is keep and add. Negative 1 times a positive 2 is a negative 2, keep and add. Okay, so that's a 1, right? That's an invisible 1 with that x. 1 times 1 is 1. Signs are the same, so it's positive. And then x times no x would just be x. Well, if y'all know me, y'all know I don't like writing 1x. So x. You can write 1x. It's totally okay. If I had my pencil, I'd just erase it, or I would turn a weird-looking 1 into an x, but just letting y'all know, I did that because all I wanted to write was x. Now let's get over to that third term in that first trinomial. It's a negative 7 times everything in the second polynomial, trinomial. They're both the same. Those are saying the exact same thing, trinomial or polynomial. So let's do 7 times 2 is 14. Signs are different, so it's negative. No x times x squared is still x squared. 7 times 2 is 14. Signs are different, so it's negative. No x times x is x. 7 times 1 is 7. Signs are the same, so it's positive. Now let's go through here and let's find things that are alike, like terms, right? So I get a 4x to the 4th, and there is no other 4x to the 4th. So I just have 4x to the 4th. Okay? Then I have a positive 4x cubed, negative 2x cubed, and that's it, right? So what I get is 4 minus 2, right? Signs are different. So I subtract, keep the sign of the larger, keep, and keep. So here we were doing the rules of the product rule. That's how I got all of those products. Once you get to this step, all of these rules that I'm doing, that's just combining like terms. That's when you keep and keep, okay? This rule came from doing this multiplication. That was keep your base, add your powers. Okay, this is keep and keep. So I understand how it can be difficult. Just got to make sure you keep your rules separated, okay? So let's go on over to our next term. What we have is our x squared terms, right? Negative x squared, or negative 2x squared, sorry. Another negative 2x squared. There's a negative 14x squared. Those are all x squareds. Looking at the numbers, negative 2, negative 2, negative 14. They're all negative. When I combine these, all I'm doing is adding negatives. So I got a little bit of negative, and then I go more negative, and then I go more negative, right? So all of these different negatives can just be added, and then you're going to keep their signs. So if you do 2 and 2, you get 4, And then if you do 4 and 14, I get 18. Altogether, that's a negative 18. Keep your variable, keep your exponent. Keep. So I did these. Now let's look. I've got a positive x and a negative 14x, right? Those signs are different. So what you do is you actually subtract the values, which would be a 1 minus 14. I get minus 13, keep and keep. And then, excuse me, get a positive 7 by itself. There's not another constant, right? I used that one, So what I get is just plus 7. So that's the product from doing this multiplication. Y'all turn the TV down. Now let's do this one. I don't know why you won't turn this TV down. Dalton, turn your TV down. I'm going to throw something at the door. Maybe get his attention. We shall see. Stay tuned. Okay, so now y'all, this one right here, I'm trying to zoom in. This one right here is a binomial multiplied to a binomial. So what you do, it's almost like, why did we do that crazy one and now we do this one, you know? So we're going to multiply those two together. And then we're going to multiply these two together. So if you do x times x, we get x squared. If you do x times 7, we get 7x. 5 times x is a 5x. 5 times 7, 35. Signs are the same. It's positive. Right here. Do you notice how those are like terms? So let's combine them. We get x squared plus 12x plus 35. That was really wonky there. That would be the answer to that question. What are you eating now? Huh? Okay. I thought you were your brother. Y'all just keep eating everything. That TV was really loud. Thank you for turning it down. Okay, y'all, there's an asterisk right here, and there's a reason, okay? So this is a binomial times a binomial. You can't really see it now, but I want to show you something. I'm going to show you it in an abstract way, okay? Try to think. So if they don't go into it in this section, that means they're probably going to go to it 12.6, 12.7. We're going to do some special multiplication technically. And what we're going to actually do is called like factoring and stuff. So I kind of want to show it to you now. And then whenever we introduce it, then I can be like, hey, that was that problem that we had the asterisk on, you know? So if you agree with me, 3x and 3x are the same term, right? Negative 8 and positive 8. Those values are the same. The signs are different, but the values are the same, right? So I'm going to go and show you something. Again, we'll touch on it and it'll make more sense later, but I do have an asterisk for a reason. I'm telling you right now that I know for a fact that these two middle terms are going to cancel. Okay, I think I'm just going to say it. Instead of writing it all out, I'm just going to say it. These two middle terms, no, I'm going to go and write it. These two middle terms are going to go ahead and cancel. Okay, and what it's called whenever we do get to it is called a difference of squares. So in parentheses, actually we don't have to do this in parentheses. Okay, so that's saying I have something squared and I'm subtracting from it something squared, right? If you see this form, it can be written as a minus b and a plus b. So guess what? I'm saying that that's my a and these are my b's. So that's all I'm going to say, y'all. Okay, because we're going to go over it later. That's going to be a difference of squares. But just believe me whenever I say, just because of the way this looks, I can tell you right now that this is the form it's going to end up in. Okay, in the homework, in exams, in everything. Don't know what happened there. This would definitely be a problem that I would include because it's a very special technique that we have the ability to apply. That equal sign in between my purple fonts there that I just highlighted means that if you have it written as a left-hand side, you can write it as a right-hand side every time. And guess what? If you have it written as the right-hand side, that's what we have now. what you can do instead of the multiplication, what you can do is just immediately jump to a squared minus b squared. Now, another reason why this has an asterisk, this is actually going to be called something special, which is FOIL. It kind of sounds weird, like we're not cooking, I'm not in the kitchen, like this is math, right? Like this is actually an acronym, which is supposed to help you remember how to do the multiplication. It is going to be the longer process. It would be awesome, totally understandable if not, but if you understand, if it's written like this, you can jump to that. And if it's written like this, you can jump to this. Okay, the left-hand side to the right-hand side is what I'm going to teach in a later video. I just kind of want you to remember this problem. So when we do get to that other video, you can be like, oh, that's what she was talking about. So let's do the multiplication. Again, binomial multiplied to another binomial is going to be when we use FOIL. The acronym for FOIL stands for first, outer, inner, and last. So let's go ahead and do that. First means the first two terms in each set of the parentheses. So the first two terms in each binomial, which would be our 3x and 3x. If you multiply those together, we get 3 times 3 is 9. And then x times x is keep and add. Just had a kid come and eat a popsicle in my ear. I had to push him away really quickly. I don't like noises. Ooh. Okay, so then scoot over to my acronym, the other letter. I get O, right? So that's outer. This is saying, right, I've got 4 terms here, right? So the outside terms would be the ones on the outside, right? Be the first term and that last term. Those are the outside terms. Multiply those together. 3 times 8 is 24. X times no x is just x, right? And those are positives, so that's positive. Then the next thing in my acronym says I for inner. Inner or the inside terms. You could hear first, outer, inside, last, but they usually say inner. These are my inner terms. Multiply those together. 8 times 3 is 24. Signs are different, so it's negative. No x times x is just x. And then L stands for last, the last term in each binomial. 8 times 8 is 64. Signs are different, so it's negative. This is what I was trying to tell you I knew it would come out to be because it was written, y'all, in this form, and I know it can be written in this form, right? I'm still not done with the problem. Do you agree with me? Those are, trying to get up some. Those are like terms, right? They both have an x with an exponent of 1. This also goes back to some other, like when we were doing linear equations and solving those, this property. Look at the numbers. Those are both 24. Look at the signs. They have different signs. If you have the same, like numerical value, right? The same number with different signs. Do you remember when we talked about additive inverses? Right? Technically, they kind of cancel each other out. Y'all, if you have $24 in your bank and you go and you spend $24, you got none dollars, right? Like they just went away. They canceled each other. So what happens is what we get is 9x squared. Those canceled, negative 64. Does that make sense? Those middle terms canceled. I tried to just guess. 9x squared negative 64 would be my answer. It was a very educated guess, though, y'all. I noticed that it was written in this right-hand side form, and I know the formula that I can write it as a left-hand side. What we'll do in the next couple of sections, I don't remember where, will be it'll show us it like this. And we're like, boom, awesome, difference of squares. You can write it like this. Okay, it kind of takes the guesswork out of things. So that would be the final answer to that problem. Okay, this is another problem where it's a binomial multiplied by a binomial. This is not what we would call a difference of squares. I want to show you why. Okay, again, we're going to go over this later, but just so you don't get it confused. If you notice, this is both A and A. That means they're the exact same, right? And then B and B, that means they're the exact same, right? Exact same, exact same, exact same, exact same. Well, the numbers 8, exact same, exact same. That's why this one was a difference of squares. Plus, they had the different signs. This one, 5x, not 5x. 3y, not 3y. So it wouldn't, in the later hallmarks, qualify for being a difference of squares. But there's absolutely nothing wrong with, hey, binomial times binomial. You could still do the FOIL. You just couldn't jump straight into the answer the way we could with that formula, okay? So let's just go ahead and do FOIL. My first two terms multiplied together, my outer terms multiplied together, my inner terms multiplied together, my last terms multiplied together. 5 times 6 is 30. Signs are the same, so it's positive. X times x, x squared. 5 times 7 is 35. Signs are different, so it's negative. X times y. It's not a product rule because they're not the same base, but you can just do x, y. Perfect. Positive 3 times a positive 6, right? It's 18. Signs are the same. We get positive. Okay, right here. I've got a y times an x. We also learned in our rules that multiplication is commutative, which means if we have y, x, you could write it as x, y. I'm going to do so because I want it to match that term, okay? And then let's multiply our last terms together. 3 times 7 is 21. Signs are different, so it's negative. Y times y, keep and add. I can clearly see that those are like terms because I wrote it in this way, right? So scoot up a little bit. I get 30x squared. Look right there, y'all. What happens if you have 35 and an 18? Your 35 is negative and your 18 is positive. Because signs are different, what you do is you're going to subtract 35 minus 18 and you get 17. Keep the sign of the larger, and then you keep your variable and you keep your exponent. Because those terms have x, y, I keep x, y. That negative 21y squared, there's nothing else like it, so it can't be combined with anything. And that would be your final answer, y'all. I think that was it. That is it. So that is how you multiply polynomials, and that should have been a good, like, well-rounded amount of, different examples and stuff. And using FOIL kind of give you a little hint of where we're going when we do special products. With number 9, we'll see like difference of squares, sum of cubes, sum of squares, the AC method. Like, we get to see a whole bunch of different stuff. Okay, so if you need anything, make sure you ask. Bye.